This arrived yesterday. It's a battery charger for a mobility scooter, and I've really got to get on with this job. I won't have much time to do any videoing, but the young man has already changed a fuse here to no success, and then he marked it up to show me where he noticed some burnt components. This capacitor down here has blown and gone short circuit. The side of this resistor is power resistor here is sort of damaged, as if it's overheated. Right down inside, and we won't be able to see it, but at least I can point to it. There's a degree of burning just around here. The power transistor here has blown, and this board is showing some heat damage. This little daughter board here is showing some heat damage at the base of it, so I don't really know whether we're going to be able to repair it or not. To get to all these components, got to remove the heat sink. That involves desoldering these 4 lugs and 3 of the power transistors. You can see the base there, there and there, and then I should be able to remove it, and that will allow me access to these components. Now, looking at the base again, this little component has those magic markings on it that indicate that it's a microcontroller, and I think if that's damaged then it'll be game over for this board, but hopefully, I don't think the sort of secondary side of the power unit is looks okay. Coming back to this other side, hopefully the burnt components are still identifiable. If not, then I'll be in trouble. And if you have no experience of this sort of thing, working on something like this is a big no-no. It's so dangerous. Never power it up. And otherwise, if you feel tempted to test things under power, you could come a cropper. Now, we've had a major blow up, and there was lots of burnt components in this area here, plus a transistor of sorts at this point, plus a transistor here, which in fact is a N-channel MOSFET. Now, he marked it in red to point to it. The green line I'll come to later, but yes, it is blown, and but we have a host of other components that are blown. Now, bearing in mind we have no information about this whatsoever, so I am working completely blind. Hopefully you can see what I'm up against. We've got that transistor there. Let's move that out of the way. We've got a blown resistor. Unfortunately, the markings are still intact on the other side, so I was able to work out the value of that, which is 0.1 of an ohm. And bearing in mind it's that low, I would suggest that this is a current sensing resistor. And we have a very titchy little 1/8 of a watt resistor that is blown to bits, and I identified this by the remnants of the colour bands as being 18 ohms. I was wrong. It isn't 18 ohms. It was the bands have been discoloured, and it turns out that this was actually 39 ohms. This is a disc ceramic which had undergone a little bit of smoke damage and in fact was intact, so that one's going to go back. It's 2.2 nanofarads, 1 kilovolt working. And here we have a little diode cum rectifier. It's not particularly unusual in that it will sustain 600 volts at 2 amps, and you can find these things quite easily, except that it has a fast recovery time of around about 35 nanoseconds. All the other devices I've found have got sort of recovery times in the 150 or so, so sort of significant factor of 5 greater than this one. Now I did feel like replacing it with a cheap and cheerful one, and I thought I'd go for the component for this one as best I could, find the best one I could for this. And they're asking a lot of money for it, you know, and I don't feel like paying a lot of money for that particular device. So I looked around for an alternative, and the closest I came up with was a SMD device, and it met the same specifications and was the price I paid for those was, well, pittance in comparison to what was being asked for that. Basically it's out of production, it'd be new old stock, and people are charging the earth for it. This little board, sadly we've had a major blow up on this board. There's a capacitor that's missing here, it's completely missing, it totally vaporised, and I'll show you some close-up pictures of that in a moment. The resistor that's by the side of it is burnt, and I reckoned that it would be 100 ohms based on sort of the curves of the remaining marks that are on there, and it was just a bit of a guess, and I said about 100 ohms, educated guess at that. There's a resistor over here that's also gone haywire, which is a 39k, and it's showing a higher resistance than the 39k. It's a funny little board, and I'll talk more about that in a moment. And this was a particular challenge to sort of get anywhere with this one. I will say that it covers what's called power factor correction. If there's a mark on the board that says it's a PFC, it refers to this charger as the main charger that it comes out of. This little board sits in there like a little piggyback board, or daughter board if you like, and soldered from the back. We've got another one over here, does a different job. So I can't compare components with that and that, because they're not alike. However, I did manage to track down another one, and able to measure the component values off of this one to specifically the capacitor. But even then, that poses me with one problem, in that although I can measure the value of that capacitor, I don't know what voltage working it is. So to decide that, we go back to our board, and these big capacitors, big electrolytics, are 50 volt working ones, and they are associated with this board here that goes in here, which is the blown up board. So I assumed that if these are 50 volts, it'd be okay to put 50 volts on them. Look for a 50 volt working. So I was looking for a sort of a 100 nanofarad 50 volt working 0805 capacitor. The 0805 being the dimensions of the capacitor. Now that proved a bit difficult for me, because when they arrived they were a different profile, lower profile than the one that's on this board, on the good board. It was sort of half the height of that one, and that started me worrying. And so I looked down the catalogues and everything and came up with that the maximum voltage working possible for that particular package with that particular value was 250 volts. So I reordered and got some capacitors of 250 volts, 0.1 microfarad or 100 nanofarads if you like, to replace that. That's where we are, and I've no idea whether this is the total body count. So I've got 3 components to deal with on this board, and I've got to engineer this one to fit an SMD diode. That's got to be reinstalled, that's got to be replaced, and that's got to be replaced. I couldn't get, strange enough, I couldn't get small resistors like that. One sort of, they seem to have dropped them from in favour of using going over to sort of SMD things. Nobody seems to stock little resistors like that anymore. So let's get a sort of quarter watt to replace that. I think there's enough room there to do the job. That's enough waffling. I want to get on with it, and hopefully when I've finished it, I've got to clean up the boards and do everything, so we'll get on with that. Sadly I don't have any of these lovely equipment that people have, like hot air guns, and well, I do have a hot air gun, but I don't have all that magic equipment that people have who manipulate with their hot air guns and just do it in seconds. It's sort of not in my equipment. I don't have such luxuries. Oops. There we go. And therefore I can't do it as quick or as professionally as they do it. I'm a bit amateurish at it all. It was quite sad really. I would really love a hot air gun. I could have removed them all with a hot air gun. Could have even burnt a lot. Now I'm going to clean up the board. A little bit of my homemade flux because I can't afford the professional stuff. And we'll sort of make sure there's plenty of flux on those 2 parts. And alright, we need to clean up the board. A little bit of meths. Right. I had a tissue if I can find one. Right, we're ready to put the new components in, but before we do that we are suffering a little bit of track damage from where the old capacitor vaporised. The pads that it sits on also vaporised, and I'm not sure what I'm going to do with that, and I'll have to look with a hand lens because I don't have a microscope. I'm not sure. One side of it's going to be earth, which is going to be there, and the other side goes the other side of the resistor. I'll have to think about that. So that's it for now. Let's try another idea. We'll get a bit of solder wick, pinch it into see if we can get the heat to run up that. Let's give it a go. de-wick that bit. Oh, that's good. Oh, it worked. Oh well, that one out there. Right. One of the problems is that we've got they're deep holes and they're filled with lead-free solder, and putting in the other type of solder, the leaded solder, to try and reduce the melting point so that we can extract it easier. I don't think it's going to work. Nope. An awful lot of solder. I was fully expecting that to wick out, but it's filled my solder wick up. Hey, done it. Right, I'm not in my pants. Let's try and clean up the board, find out where the other hole is. With all these jobs, it's experience, and generally speaking, the cleaner the board, the easier it is to achieve what you're after doing. Makes soldering a lot easier. I've no idea what's going on there. It's really sort of burnt looking, and I suspect there's a coating on this board, what they call a conformal coating, to sort of protect it against moisture, and I think that's what's causing that sort of burn there. As we're burning through that sort of clear varnish. Now before I go on to mounting the rest of the components, here's a little bit of solder wick where I screwed it up at the end, got the solder melting on the holes that I wanted to unblock, and then pushed the solder wick in, and here's where it's absorbed the solder back up into the wick. I thought I'd share that with you because it worked so well for me. It might help a few other people. I'm just cleaning the leads up of a component that I'm putting back because it isn't faulty, and I tape that down to sort of help hold it in place while I put the solder wick on the lead. It sort of saves chasing it around all over the place. I think it's clean enough. Silly little tip, but it saves a lot of frustration. The capacitor C29. This is this one which I cleaned up earlier. I put her in place. Bang a set of pliers under the board because give it a bit of clearance for the lead. Over there. In. I'm going to use a bit of blue tack to sort of hold her there while I flip it over. Done. We've got to replace the resistor and the capacitor on this board, but the pads for the capacitor had completely evaporated when with the device, and as you can see the resistor is R19 and the capacitor C1. I put some copper foil in place, and I'll scratch back a little bit of the track, and to do that I used a new razor blade. This foil is a sticky back foil, and hopefully it'll stick to the board okay. I've done some sort of tests with it before and had a moderate degree of success. This is its first real application, and I'm hoping that once we solder the components in, the exposed copper will all get flooded with solder and I'll hold it all together. I've replaced that resistor, repaired the PCB track with copper foils best I can, and then I've soldered in a new resistor there and a new capacitor. I've got to get a move on with this job because the boss wants me to do a bit of decorating, like wallpaper hanging. It is the first time I've ever soldered components that small, well, taking the job seriously, and I managed that with ordinary soldering iron. If I can do it, and I'm only average at this sort of thing, anybody could do it with a little bit of patience and perhaps a little bit of practice. There's a little transistor there going to the terminals of the transistor that actually burnt out, and I would have expected that to have blown, but I've tested it with a meter in diode mode and the junctions don't seem to be affected, so I'm leaving them well enough alone, not taking that out and replacing it. Perhaps I should do, but as a precaution, but you can get too cautious when you're repairing things and think, oh, change this, change that, change that, change that. There's absolutely nothing wrong with it, and fingers crossed there's nothing wrong with that. This now has got to be refitted to the board, and it's going to be a bit of a trouble because it's got like 9 leads that got to go through the vacant holes on the board, and that can be a bit tricky. Let's see if I can get them in. If they line up, it'd be a miracle. I'm pretty close. They look like they're in. They don't. Which ones? Can't believe it. Well, I can assure you that's a bit of luck. If they're all in, then that is a bit of luck. Now all I've got to do is solder those in. Now let's get the other little board in. It's quite delicate. Let's see, where it is. Here I'm using a bit of this white tack as opposed to blue tack. I'm going to use it to hold the board in place while I solder. And I've got to get it in place. Need a pair of tweezers. Okay, the old tweezers will do. That's it. What's in place. Right, now I've pushed the blue tack in there, it's holding the board in place. And they're all lined up nicely. And I don't know why I keep calling it blue tack, it's just habit. It's white tack. No, it's not perfect, but we'll worry about the others first. Oh God. Isn't it marvellous that... There you go. When I look at this, I begin to wonder how on earth I managed to solder the other thing. Let's do this one properly. Flick around. Yeah, let's get this one soldered in. If you are going to do this type of work, you really ought to get yourself a temperature controlled soldering iron, and it'll make life a lot easier for yourself. Right. Yeah, horrible. Hopefully it'll work. Take out blue tack. Now, I didn't solder these to the board because they are a complete, utter nightmare. All the transistors are insulated away from this by sort of a small sort of conductive sort of browny coloured strip along there. Not conductive, but a brown strip, that sort of insulating strip that keeps it away from this, and this goes down to ground. But these little lugs can be a nightmare to remove, you know, to desolder. And I'm very fortunate in that I have a fairly good desoldering tool. And that helps, and in combination with using leaded solder and you know, sort of managed to eventually free these off. But I did resort to another technique, which is to sort of get a fairly hefty broad screwdriver blade or bladed instrument. I don't know if I've got anything to hand. Words farmer. Oh, this will do. So just to demonstrate what we're talking about. Between the edge of the tool, I sort of put a bladed instrument in there and twisted it round while I was putting the iron on that part there. And as soon as I found a little bit of movement, I stopped and then went up to the next one. Got it warm again, and then twist. As soon as I feel a little bit of movement, stop, go around to this one, put it in here, melt this one again. As soon as I feel a twist, as soon as I feel a little bit of movement, stop, stop, keep on going round and round, and sort of the process of walking this assembly out of its position. But of course I did desolder the transistors first. You could, if you like, probably, well, I don't think you could, but you certainly get a screwdriver in on one of those to sort of, if you could free them off by undoing these screws, then you could sort of take the transistors out individually. That's how I did it. It was a pain. I wouldn't recommend that anybody does this, because as soon as you put mains power on a unit, you're in a danger area, and we're going to sort of see if it works. Well, blows up on us, and I've got a funny feeling it's going to blow up. Gut feeling, you know, call it what you will. I'm not happy about doing this. So the camera's rolling. Look, I've still got the plug in my hand, so I'm not gonna sort of hold this and right, yeah, let's get her in position so you can have a good laugh if it all pops and makes smoke and God knows what, or explodes. Watch a grown man cry afterwards, because I'll have to have another go at repairing it and finding out what's wrong with it. And honestly, the chances of this working, if I haven't found all the broken components, then the chances is working are nil. If I found all the broken components, the chances is working 50-50, because I'm assuming that all the component sites, all the power MOSFETs from China, and of course we can only speculate as to whether we've got a proper device or not. I don't think you can see it from there, or maybe, I don't know. There's a little light bulb here. It should flash green, I think, when I plug it in. Of course it may go bang. I'll stand back. Everything's running. Well, unplug it. Nothing happened. Well, that was interesting, wasn't it? Nothing happened. I slept on the problem and stripped the whole thing down again and thought about this a little bit logically. And all that I've done so far is to replace a few components that I found faulty, including this resistor, including this transistor, and I've repaired this little board and replaced 3 components on there, 2 resistors and 1 capacitor. This IC is designed for power factor correction, and I wasn't sure how it operated within the power unit, but as all the problems are generated around this device, I was able to download the specification for it, and within the specification there's a rather telling circuit diagram for recommended mode of operation. But before we look at that, one of the things I did find rather disappointing when I looked at it all, and it's just this transistor. You may be able to see green pen marks on the legs. Now that was put on there. That was put on there before the device was mounted on the printed circuit board. Now one of the reasons may be that they were selecting these devices to run on one particular part of their parameter, and you know, so you test half a dozen of them and select the one that best fits your requirements, and you give it a green mark, discard the others. It may be that they just tested it before installing it, because once it's installed on the PCB, it's very difficult to change it if it's gone wrong. Now, that was blown, and I've replaced it over there. The green marks did worry me a bit, because I have some experience of selecting components specifically to run in power units. Not a practice that I would recommend, and it was one in an area where we were looking for a relatively high efficiency with a power unit. Let's have a look at the circuit diagram of this integrated circuit. Okay. You'll have to excuse me, I've been pointing to the wrong board all the time. It's this little board, not this one, which is on the other side of the board and contains a few more components. This was the one that had the major blow up. Now, I hadn't realised that pin 7 of the chip is the output that drives the transistor, this transistor. And as this has blown up, I'm not surprised that I'm having trouble, or could have trouble, with this chip. Pin, as you can see, pin 4 deals with the current sensing. 0.1 ohm resistor. We've got a 0.1 ohm resistor that's blown up on the board. The transistor's blown up on the board. There are 2 points, goes direct into that chip. I've traced them through on this little board to the outputs down there. I hadn't thought about this properly when I first started playing about with this power unit and not dived in and just changed the components. I would have replaced that at the same time. I thought I could get away with it. I thought it was protected enough. Obviously not. I say obviously not, I don't know. But the next stage is to change that component. I've been all over the power unit, completely over the power unit, and I can't find any single component that's blown, except that accepting that I can't test the integrated circuits that are on this board, and there are a few. There's this one that I'm going to change. On this little board there's one there and another 2 there, and I hope that they're not damaged. And if we turn over this board, on the back of it, you can see that we've got 4 devices here, 1, 2, 3, 4. And to crown it all, this one is a microcontroller, and if that's gone, I was wondering, I wouldn't really want to get into the realms of writing software for that. But everything that's been damaged has been on the primary side, the main side of the power unit. And I think that the damage is limited to this area, specifically this transistor, the components associated with that transistor, and also this board. So this little board is crammed with small little Zener diodes, resistors, and that's what it's mostly composed of. And one of the resistors that I replaced, which was this one here, was open circuit and comes out on this pin here, and this pin actually goes nowhere. Theoretically there's a space for a jumper to run. I think it's It's either J1 or J2, but it isn't populated with a piece of wire. Hence it's not used, and it's rather left me wondering why, but I'm not going to question that. The resistor needed to be replaced because it's in a bit of a loop that goes around here. The sort of voltages that are being used, a single resistor would not survive. It would be outside of its working voltage, and they have chosen to put lots of them in series, sort of daisy chain them along to make sure that the voltages don't exceed the recommended working voltage. I think that's really all I've got to say about that. The big question is sourcing components. Now I could source this from in the UK and buy it from one of the smaller distributors, but I'm a little bit loath to do that because in the past I've bought stuff from them and I've ended up with fake goods. Not always, but well, only one occasion where once is enough. So I'm going to buy them from China. If I was buying them from some of the bigger suppliers, then I would feel confident that I was buying a product that would work. But buying from some of the smaller distributors who source their components in China, I thought, well, blow it, I'll buy straight from China and take my chances. I think that's about all I've got to say. I'm going to have to end it here because we're going to have to wait another month or so to ensure that we've got the component, and hopefully we'll come back, try that, fingers crossed it works.